Good evening to all. Myself Anand. I am working as assistant professor in the Department of Mechatronics Engineering. So now I am going to discuss about the topic of motor duty classification in electrical drives and control unit systems. So we have classified into 8 types. The first one is continuous duty. So what is meant by duty? What is meant by motor duty? So all of you know motor is nothing but electromechanical device which converts the electrical energy into mechanical energy, or this is with the help of this motor we are creating the rotational energy, mechanical force. What is meant by duty? So duty is nothing but the working period, working time of the particular device is called a duty. So if it is motor duty, now the motor running time is called a motor duty. So we have classified into 8 types: the continuous duty, short time duty, intermittent periodic duty with starting, and then intermittent periodic duty with starting and breaking, continuous duty with periodic loading, continuous duty with starting and breaking, continuous duty with periodic speed changes. These are the some of the classification from the motor duty. Okay, we start from continuous duty. This represents the motor operation at constant load enough for the motor temperature to reach the steady state value. Best example is the fan. The fan is normally with the fan without regulator is running in a constant speed. The temperature rise also in constant mode, change with respect to time. And then some of the example is the paper drive, compressor, and then conveyor. So these are the some of the example drive for continuous duty. So the left graphs represent the load torque of this continuous duty motor, change with respect to time. Likewise, the right side, the temperature rise of the motor, change with respect to time. And then short time duty, in this type of operation the motor is operated for a short period which is less than the heating time constant of the motor. For example, if the motor is reached the high temperature, now it will shut down. For example, crane drive, household applications, valves, etc. Here we see in the temperature rise graph, it will reduce or turn off the motor operation before they reach the maximum point of the temperature. So and then intermediate periodic duty, in this type of operation have number of duty cycles which contains a period of running at a constant load and rest periods. For example, the first the load torque and then time graph, see this time graph and load torque graph. So we have intermediately running conditions, as likewise intermediately switch off conditions. So likewise the temperature also increased and decreased. And then intermediate periodic duty with starting, in has starting, running, and constant load resting periods. The rest period is short compared to the time required to the cool off to ambient temperature. For best example is metal cutting and drilling tool drives. So another example for the intermediate period starting is our motorcycle and then car. So we are starting that engine with high starting torque, for example 1 or first or second gear, and then in running condition the torque of the motor in normal conditions like third, fourth, and fifth gear. So this is a comparison between a normal automobile with the intermediate period duty with starting motors. Example, metal cutting and drilling tools drives. And then final one is intermediate periodic duty, it's starting and braking. So in this system the starter has high load and then braking has negative torque. So then only the torque generated in less than 0, that is negative torque. So this negative torque creating during the braking time. So in this operation contains of the period of starting, the period of operation, a constant load, and rest period, with operating at the rest period being 2 shots for the respective steady state temperature to be attained. Example, billet mill drives and then manipulator drives, electric submersible drives. So these are the some of the motor duty classifications of the electrical drive systems.